When you first start writing modules, the most natural pattern is named exports. You have a collection of related functions, say, a set of string utilities, and you want to export all of them from one file. The pattern is straightforward. You attach each function directly to the exports object. Exports.capitalize equals function, str. Exports.truncate equals function, str, len. Exports.slugify equals function, str. The caller uses require to get the exports object, then accesses each function by name, const, capitalize, truncate, equals require, /string utils. This is the simplest pattern, and it's the right choice when your module provides multiple independent utilities that callers will mix and match. Node.js's own standard library modules follow this pattern extensively. The path module is a perfect example. Path.join, path.resolve, path.dirname, path.xname all attached to the same exports object, all independent utilities that do different things with file paths. The named exports pattern is also the most transparent. When someone does require./myModule, they get an object and they can inspect what's on it. The API surface is explicit. Documentation tools can introspect it automatically. There's no mystery about what the module provides. The limitation is equally clear. This pattern doesn't support initialization logic that needs to run once, doesn't support stateful modules that need a constructor, and doesn't let you export a single primary thing like a class or a factory function. For those cases, you'll use one of the other patterns. But for utility collections, the named exports pattern is idiomatic, readable, and exactly what the community expects. James Halliday, known online as Substack, is one of the most prolific authors in the NPM ecosystem. He wrote modules like Browserify, Through, Mini-Mist, and hundreds of others. And he popularized a distinctive style, module.exports equals a single function. When you require his modules, you get a function. Not an object with methods. A function you call directly. This became known as the Substack pattern, and it's the right choice when your module has one clear primary behavior. The pattern is simple, module.exports equals function, args, return something. The caller writes const dothing equals require, /myModule, dothing, args. No property access needed. The module is the function. You can still attach properties to the exported function. In JavaScript, functions are objects. So you might export a main function and attach a few helper functions or configuration properties to it. But the primary interface is a direct function call, not a method access on an object. The book highlights why this pattern is powerful. It communicates intent. When a module exports a single function, it's saying this module does one thing. The interface is focused. There's no opportunity for callers to poke around and call internal methods they shouldn't be calling. It enforces good boundaries. A common extension of this pattern is the factory function variant. Instead of your module directly being a utility function, module.exports is a function that creates and returns an object. You call it with configuration arguments, and it creates a customized instance. This is how many configuration-driven modules work. Require the module, call it with your options, get back a configured object. Clean, explicit, and unit testable. Two closely related but importantly different patterns share this slide. Exporting a class and exporting an instance look similar, but their implications are completely different. When you export a class, module.exports equals class mything, every caller that requires your module gets the class itself. Each caller creates its own instance with new mything. Multiple instances exist simultaneously, each with its own state. This is the right pattern when the module represents a type that callers will instantiate multiple times with different configurations. A database connection pool. An HTTP client. A logger with specific settings. Each caller needs their own. When you export an instance, module.exports equals new mything, every caller that requires your module gets the same instance. Remember that modules are cached. The first require creates the instance, and every subsequent require returns the cached module, which means returning that same instance. Multiple callers requiring the module share one object. This leverages the module cache intentionally to implement the singleton pattern. This is the right pattern for genuinely shared resources. A configuration object loaded from disk. A database connection shared across the application. A shared event bus. By exporting an instance, you guarantee that every part of your application is using the same object with the same state. The distinction between these two patterns is the difference between a blueprint and a building. Exporting a class gives callers a blueprint. Exporting an instance gives callers a building that already exists. Callers of the class build their own. Callers of the instance share yours. The choice depends entirely on whether you want shared state or isolated state. The final module definition pattern in this chapter is one that the book treats with the seriousness it deserves: monkey patching. Unlike the other patterns, which are about what you export, monkey patching is about what you modify, specifically, modifying other modules or the global scope. Monkey patching is the practice of reaching into a loaded module's exports or into a global object and replacing or augmenting its properties. You require the HTTP module and replace its request function with your own version that adds logging. You require a third-party library and patch a method to fix a bug before an official patch is released. The reason the book includes monkey patching as a pattern rather than categorically banning it is that it's used in practice and you will encounter it. Testing libraries like Sinon use it extensively for mocking. Some legacy compatibility shims work this way. The require-based module cache makes monkey patching work. Because modules are singletons, any code that requires the same module after you've patched it will see your patched version. Everyone shares the same module object. The book is clear-eyed about the downsides. Monkey patching creates invisible dependencies. Your module implicitly depends on another module being loaded and patchable, without declaring that dependency anywhere. It creates fragility. The module you're patching might change its internal structure. It creates confusion. When something breaks, the behavior change is invisible and hard to trace. The rule is simple: if you ever reach for monkey patching in production application code, stop and ask whether there's a cleaner design. For tests, it's acceptable with proper setup and teardown. For application code, it's almost always the wrong answer.